All right, LeetCode 17, letter combinations of a phone number. We are given a string, 1 to 4 digits. The digits can be 2 through 9. Those represent the number on a keypad of a phone. And we need to take each digit, grab the letter group for that digit, and for each character, we're going to combine it with the character from the other digits to create individual strings that we're going to return back. So we have 2 and 3. 2 has ABC, 3 has D, E, F. We are going to have A and D, A and E, A and F, so forth, or so on and so forth. You can read it over here. Let's get on with it. We're going to solve this in C#. We're going to use a strategy pattern. If you're not familiar with that, you will be by the time you finish this video. That's my dog. Apparently he agreed with me. So the first thing you want to do with strategy pattern is a strategy represents an algorithm. So we need to make our algorithm classes. So what are those going to be? We're going to have a 2-digit algorithm, a 3, and a 4. The 0 digits and the 1 digit are done directly inside the method that LeetCode calls, the function it calls. So right here, we're checking for a digits length of 1. We're just going to combine each individual character. Like if it's a 2, we're just going to grab the ABC. Each one of those is going to be a string. We're going to throw them in a list, return it. That's all we got to do. In the case of 0, right here, null or empty, we're just going to return the result, which is an empty list of strings. So it's just going to be an empty string. So what else do we have? We got our strategies down here. So let's go back up here. So for each of our strategy classes, our algorithm classes, what we're going to do, each one implements an interface. So in C#, an interface describes some kind of behavior that you're going to want to implement. In our case, there's a process function right there. So every class that implements this interface has to have a process function, and we can see it up here. This is our interface. You can add methods to it if you want. If you wanted something else in there, do it. Now it's important to know also that you can change out the guts of this algorithm and maybe switch it over to a backtracking algorithm. That's all you'd have to change in this. So we've got our algorithm classes, and then we've got a wrapper class. Usually out in the field when you get a job working out there, if you're new to this, this is called a wrapper class. So what that's going to hold is a strategy right here. And then in the constructor, we're going to pass this in. This is called dependency injection. So we're going to inject our dependencies because this class, you can't instantiate it without having the strategy. See, because you can do anything. There's no point in it. So once you have that, then we got to call it. So we can call it without having to know if it's a 2-digit, a 3-digit, or a 4-digit algorithm. And that's what's beautiful about this is we just load up a generic interface or interface letter combination strategy interface, those names, and then we just call it. So whatever we instantiate our object with, that's what's going to be called down here. So strategy represents that 2-digit, 3-digit, or 4-digit. Okay, that's the beauty of it. So our actual implementations are just for each loops. Now I believe this is a ON. Let's see. So N is going to be each letter group times M, which is each letter in the group, raised to the nth power. So yeah, I believe that's it. Let's see. I think that's all. Is it? I explained the class, the interface. Okay, let's go through this. So LeetCode calls letter combinations. We're going to create our results list, and then we're going to check for null or empty. We're going to just return the empty list. if it's null or empty. We're going to create a dictionary that maps our phone number, our number, to the letter group. If it's 1 digit, we're just going to go through and create strings for each of the letters in that group. And then we're going to pick a strategy. We can run it with a wrapper or without the wrapper, whichever you want to do. Let's run it. Well, look here first. So we go off the length, digits.length. If it's 2, then we create a combination solver. We pass in what is it, our digits for whatever letters it's going to be or number it is, whatever it is. The digits 0 and 1, so 2 and 3. So if it's 2 and 3, we're going to grab A, B, C, D, E, F, and that's what's going to be thrown in there. And same for 3 digits, 4 digits. That's it, really. Up here without the wrapper class, we're just going to return the result of that. So we're just going to new up a 2-digit, a 3-digit, a 4-digit, throw in our letters to it, call the process, and just return it directly. Otherwise, we call the wrapper function, pass in the 2-digit, 3-digit, or 4 digits. Anything that implements our interface. And that's it on that. Same thing. Let's run it. All right, 1 millisecond, 44.2, it beats. That's it on that. Memory, it beats 82. So, yeah, I think that's pretty good. That's it. Like, share, subscribe, make a bumper sticker. I'll throw this up on my GitHub. I think my GitHub is in the description of my account or somewhere on there. Not sure. You can always Google my name, Kirk Burleson. It should pull up my GitHub. All right, that's it. I will see you guys on the next one. Play around with it.